Hey, welcome to SGT Time with Sergeant Rod. I'm Sergeant Rod, and here's today's lesson. All right, I'm gonna face down. Okay, so I want you guys to go ahead and add this page into your journal, and we're gonna call this page Malthusian Theory. Now, like environmental determinism and possibilism, Malthusian theory is a theory, right? And we'll look at several theories in AP Human. All right, I guess you could say that this would be our third after determinism and possibilism. But Malthusian theory is named after a gentleman by the name of Thomas Malthus. And Thomas Malthus lived in the 1700s. All right, and he's the one who came up with this theory, so they call it Malthusian theory. Makes sense. And here's the real note I want you to have in your journal, and then we'll draw Malthusian theory here in a second. Malthusian theory and its critiques wait for it, are used to analyze population growth. I'm sorry, I don't know why I said population growth, are used to analyze population change, which for the most part means growth, but it could mean the opposite, population change and its consequences. So let's see this graphed. All right. So we're going to do, I'm going to draw a little graph down here. You guys go ahead and draw this in your journals as well. This x-axis is going to represent time. All right, so we'll say that this is time. So the further we move down the axis, the more time has passed. And this is going to represent, for lack of a better word, I don't know that we, quantity. There's going to be two things I'll put on here. So the first line is going to be population. And we say that population follows what we call an exponential curve, which is something, depending on the math class you've taken, you might have seen before. An exponential curve is one that starts out modest and then suddenly looks like a hockey puck. All right? I can't talk today. Hockey stick resembles a little more of a hockey stick. And this is what population, this resembles, over time the population of the Earth, right? Which we started out, a couple, less than 1 billion people. And then I think we hit 1 billion, and I think in the video I showed you it was 1800, which you could say maybe it was right about there. And then it only took 130 years for the population to double. And then it doubled again in only 30 years after that? And then it doubled again in 12 years, and then 12 years. And so you could see if it keeps doubling like that, it's just going to grow exponentially. It's just jutting out into the stratosphere. This is also, for those who are interested in climate change, this is kind of what you see as far as the level of carbon dioxide in the atmosphere caused by, CO2 caused by things like, cars and the cutting of trees that we've done has caused, CO2 levels to skyrocket into the atmosphere as well, and that in turn is causing climate change. So the idea of an exponential curve, this is something you see a lot. It's real popular in science and math. Malthus, so I'll say that this was, this represents population, which I'll just abbreviate. Well, I won't abbreviate. I'll go ahead and write the whole thing. Population, though, okay, unlike population, though, which followed an exponential curve, the food supply followed what we call a linear curve. So I'm going to do, I'm going to grab a different color for food supply. Okay, I got a couple different colors here now. Food supply I'll do in the color purple. Why not? So food supply grows linearly, all right? It does not follow an exponential curve, right? it goes in a straight line. Over time, the amount of food that we can produce goes up incrementally, always by the same amount. So if we're in this position right here, we have what we can call abundance. I'll go ahead and shave that in. Yes, and abundance is when the population is less than the supply of food. We have an abundant amount of food, right? There's enough food for everyone. Once we cross this point, though, you can see right here, which I'm going to label the catastrophic point. Then suddenly the supply of food is less than what we need to feed the population. And so once we've crossed that, you could shade this area in, and we could call this area scarcity, right? Now there's suddenly not enough food for everyone. So this is what Malthus feared, right? This was his theory. At some point in the future, he wasn't sure when, but he knew that the population was growing exponentially. He said the food supply will not be able to keep up. At some point in the future, we'll hit a catastrophic point, and then we'll enter an age of scarcity and human suffering and famine or hunger, maybe caused by famine. What Malthus failed to realize, however, is the idea, right, inherent in possibilism, which is that, maybe with human ingenuity, we could do things to grow our food supply so that it doesn't have to follow this linear pattern. This is what he didn't understand in the 1700s, that the food supply doesn't necessarily have to go in this linear straight path, right? We have ways today, which we'll learn about in a whole unit on agriculture, how humans have been able to actually take the food supply line and make it almost mimic the population line, right? So that there actually is enough food for everyone. This isn't to say that everyone in the world has enough food and that nobody's going hungry. Of course, we know that hunger is a big problem in certain parts of the world. But we will say that Malthus was wrong in quite a few areas. And though there are people who still believe in this idea, they say we still have not hit the catastrophic point, but it is coming. They can't necessarily say when, but those people who believe that we are going to hit this point, we would call them neo-Malthusian followers. Neo-Malthus, a neo-Malthusian follower. Yeah, sounds that's a tongue twister. Okay. There you guys are. I think that was it. And I'm ending the video at about 8 minutes, which is 3 minutes longer than I promised. But make sure you got Malthusian Theory in your journal. All right, we'll talk about it some more.